So here's an example involving a composition of functions. In this example, we're going to let f of x equal the function 7x plus 2, and g of x is equal to the square root of x minus 5. The first part here is asking for f composed with g of x and its domain. So what this notation means, here if we work on part A, f composed with g of x, oops, here, parentheses going the wrong way, means we're going to take f, I'm going to switch to color coding this, f of g of x. And so, let's take all these lids off. That's equal to, seeing about how I want to line this up, f of, okay, so now I'm going to replace the g of x here with what g of x is equal to, square root of x minus 5. So this is f of the square root of x minus 5. Now what this function notation means is we're going to take the function f and input the square root of x minus 5. This is our new input. So this equation up here, f of x equals 7x plus 2, the x is just a placeholder. So whatever variable you have here is just a placeholder on this side of the equation for whatever input you're given in a specific, in a certain case. So in this case, the input, what we're going to input is the square root of x minus 5. So f of the square root of x minus 5 is, so if I follow the instructions from this equation, it's 7 times the input, so it's 7 times the input, which is square root of x minus 5 plus 2. And there's nothing that you can combine there. We can't combine square roots with things that are not under a square root, so we would leave it in this form here. So this is f composed with g of x. Now let me come back and handle domain in a second. Here, let's move on to part B. So sticking with the idea of what we're doing here, it turns out order matters in this composition operation here. G composed with f is going to give us a different result. Okay, so let's see how that happens. So now we've got G as the outer layer here. So this is G of f. So here's where we, well, I guess I'll put f of x. I'll do it the same way I wrote it up above. But I'm going to replace f of x. F of x is equal to 7x plus 2. And let me erase this. So now the outer function is the g function. So we would go to the equation for this function named g. We see the square root of x minus 5. But remember, the x in this side is just a placeholder for the input, which in this case the input is 7x plus 2. So g of 7x plus 2 is equal to the square root, so I'm just following the instructions here, of x, which we're replacing, so that's the input, we're replacing that with 7x plus 2 minus 5. And that's under the radical. There. Okay, now since that's under the radical, we can combine the plus 2 and the minus 5. So this can be simplified just a little bit to the square root of 7x minus 3 when you combine the two constant terms here. Okay, but notice that we do get a different function. Now, the problem also asked for the domain of each of these functions. So when you're finding the domain of a function, what we're really looking for is the set of inputs for which the output will be a real number. So the things that can happen in your function that would not give you a real number for your output would be dividing by 0. So if you see a variable in a denominator, then you should set that, figure out what's going to make that denominator equal to 0 and say x cannot equal blank. So if you have, you know, something over x minus 1, then your domain would be x not equal to 1. All x that are not equal to 1. we don't have a dividing by a variable expression in either of these functions, so we're not worried about that. But with square roots, you're worried about, we don't want to get imaginary numbers as our output. We want real numbers for the output when we're finding domain. So in order for, let's go with this expression, in order for this to generate a real number, what's under the radical, that's really all we're focused on, this would need to be greater than or equal to 0. And that's true anytime you're dealing with a function that involves an even root, like a square root. Most likely that's what you're going to see. If you see a square root in your function, then you need to guarantee that whatever expression you have under that square root, in this case x minus 5, you need to guarantee that that's going to be 0 or bigger. That way you get a real number when you take the square root. So if I just add 5 to both sides of this equation, I get x is greater than or equal to 5. So the domain for f composed with g is all x greater than or equal to 5, which, by the way, if you're looking for interval notation for that, you can draw a little number line here. Here's 5. X is supposed to be bigger than 5, so that's over here, or equal to, so we use a hard square bracket to represent that. So the domain for part A is bracket 5 to infinity. There's your domain going along with, like I said, part A, so I'll divide it there. So same concept here. In part B, we would need to guarantee that what's under the radical, in this case 7x minus 3, is greater than or equal to 0. So if I add 3 to both sides, that means that 7x needs to be greater than or equal to 3. And if I divide by 7 on both sides, that means that x needs to be greater than or equal to 3/7. And the green, I know, maybe it doesn't show up as well as I wish. So if you drew the number line, and I'll erase this here to give myself a little room. Here's 3/7. X needs to be bigger than 3/7, so I shade to the right, or equal to, so that's a hard bracket. So the domain for part B is bracket 3/7 to infinity.